Hello students, welcome back to this wonderful chapter Chemical Kinetics. Here in this module, we will cover some multiple choice questions on isolation method for finding order of the reaction. So what are we waiting for? Here's the question. For a reaction A plus 2B gives C plus D, the following data was obtained. Here kinetic data has been given to us. The initial concentration of A, B and the initial rate of formation of D. The correct rate law expression will be, and the options are A, rate is equal to A concentration into B concentration. B, rate is equal to A concentration into B concentration square. C, A concentration square into B concentration square. And option D, A concentration square into concentration of B. Now what we will do here is, we will use this kinetic data, obtain order of the reaction, and we'll substitute the value of order in the rate law expression. So we'll get the answer. Now here, when concentration of A is constant, look at the second and the third row of the given data. When the concentration of A is constant, this is the rate law expression. Rate is equal to K dash into concentration of B raised to beta. All the constant terms have been taken together under K dash. Now here, when concentration of B is doubled, it's pretty obvious from the values. When concentration of B is doubled, the rate increases by a factor of 4. Now here, let the beta value be 2 and the concentration of B be doubled. When we substitute all these values in the rate law expression, we get rate is equal to K dash into 4 to B raised to 2. Which means that when the beta value is taken as 2, the rate is indeed increasing by a factor of 4. This justifies the given data, so the value of beta is 2. We've got the value of beta, we'll do something similar to obtain the value of alpha. Now when the concentration of B is kept constant, check the first row and the last row. The concentration of B is constant here, and the concentration of A is increased 4 times. When this happens, the rate also increases by a factor of 4. Now this is the rate law. Rate is equal to K dash into concentration of A raised to alpha. So here when we substitute all these values, A being increased 4 times, and let's take the value of alpha as 1. So when we put these values in the rate law expression, we will get rate is equal to K dash into 4 into A concentration raised to 1. Once again, now the rate is indeed increasing by a factor of 4. So when the value of alpha is 1 and the concentration of A is quadrupled, increased 4 times, the rate also increases 4 times. This justifies the given data, which means the value of alpha is indeed 1. Now, the value of alpha is 1 and the value of beta is 2. So this should give us the correct answer. We have our options here. The value of alpha should be 1 and beta should be 2, which means the correct answer is obviously option B. So this is how you have to solve it. Let's take a similar question now. The rate of a reaction between A and B increases by a factor of 100 when the concentration of A is changed from 0.1 molar to 1 molar. The order of the reaction with respect to A is, so we have been told that when the concentration of A is increased 10 times from 0.1 to 1, so that means 10 times the concentration of A is being increased, the rate increases by a factor of 100. So here the options are A 10, B 1, C 3 and D 2. Here once again we know the rate law expression. Rate is equal to K into concentration of A raised to alpha into B raised to beta. Now when concentration of B is constant, this is the rate law expression. Rate is equal to K dash into concentration of A raised to alpha. Here, let's figure out what all has been given to us in the question. When the concentration of A is increased 10 times from 0.1 to 1 molar, when that happens, concentration of A is 10 times its initial value. So here, if alpha is 2, if we take the value of alpha as 2 and the concentration of A is increased 10 times, we can say that rate is equal to K dash into 100 into A square. And this justifies the given data, because here if we see, the rate increases by a factor of 100, which means the alpha value should be 2. So when the alpha is 2 and concentration of A is increased 10 times, the rate increases by a factor of 100. So the answer is 2. So D has to be the correct option. This is how you solve the numericals and multiple choice questions based on isolation method. Have you all understood that? Thank you very much.